Welcome to another session of Everyday Mathematics. Here at Everyday Mathematics, as we always say, we do enjoy solving the harder problems, but also we see and appreciate the beauty in the simpler problems. So today, we are still on the MIT 2022 Integration B. We are still on this very topic of absolutes. Very interesting problem, piqued our interest, and that is from the semifinal of the 2022 Integration B. And that is semifinal 2, problem number 1. And as you can see, it is the integral from x equals to -1 to +1 of the absolute value of x minus 2/3. That entire value is taken as an absolute minus 2/3 squared, again, the absolute of that entire expression, minus 2/3 cubed, again, the absolute of the entire expression, minus 2 to the power, 2/3 to the power 4, absolute, and so on to infinity. So this is a very interesting problem. I hope you will stick around and watch how we'll try to solve this problem. But before I do that, I would like to thank our subscribers, our returning subscribers. Thank you so much for just hanging around with us and for supporting us. For first-time visitors, I hope you stick around, watch what we do, or you could stop the video and subscribe to our channel. To those of you who are here for the second, third, or fourth time haven't subscribed, we do ask you to subscribe to our channel. For that helps us a lot. It gives us the visibility that we need. If you'd like to receive periodic notifications when we do update when we do upload our videos, please press on the notification bell. So going on to the solution of this problem, a few things that we should note is that if we consider the integrand f to be fx, and then we look at the core of this expression, that's the absolute value of x, since the absolute value of negative x equals to the absolute value of the x, then we can say that the integrand fx is symmetrical about the y-axis. In mathematical terms, you could say the function fx is even. Therefore, we could also express that f of negative x equals to fx. And thus, the integral of this integrand fx from -1 to +1 is also the same as twice the integral of the same integrand from 0 to 1. And that is twice of this, because we have the same thing on both the negative and the positive sides of this equation. Now, the other thing that is worth noting is that fx is linear and monotonic. That means that we have a simple line that is either increasing or decreasing. When this initial absolute term, x minus 2/3, is greater than all things that have been extracted from it. And therefore, that means that x minus 2/3 absolute is greater than 2/3 squared. This is a geometric progression. We have the initial value, 2/3 squared, divided by 1 minus the common ratio, which is 1/3. And thus, therefore, x minus 2/3 is greater than 2/3 squared over 2/3. So the 2's here cancel, and 1/3 cancels with the second 3 in the numerator. So we're left with x minus 2/3 absolute is greater than a third. Now, since we have this absolute term around here, it means that this value could either be negative or positive. So we can divide that into two categories where x minus 2 over 3 is greater than a third, or when x minus 2 over 3, when you divide negative around, this inequality sign flips, is less than a third negative. And so in the instance where x minus 2 over 3 is greater than a third, x is greater than 1. So in that domain, we have a monotonically increasing value of fx. And then in the region x minus 2 over 3 is less than negative a third, x is less than a third. So between 0 and 1 over 3, we have a monotonic behavior that's also linear in nature. So we have a defined behavior of fx between 0 and a third and between 1 and infinity. But what about between a third and 1? So there's a black box there. Things we can do is still focusing on fx. We seem to see that fx is symmetrical about 2 over 3 in the 1 over 3 to 1, x equals to a third to 1 domain. And that we can show by saying let x equals to 2 over 3 plus t. Then that means it's 2 over 3 plus t inside f. We plug it in place of x. The 2 over 3 cancels out, and so we're left with an absolute value of t minus 2 over 3 squared, absolute, and so on and so on. Now, when x is equal to 2 over 3 minus t, and we repeat the same process, since the absolute value of negative x is what we get between these absolute terms, and we know the absolute value of negative x is the same as absolute value of positive x. So we see this relation, these two values are equal. Therefore, f of 2 over 3 plus t is equals to f of 2 over 3 minus t. That's a very important thing to note. Now, one other thing that we would like to point out is that if the integral I is the integral from -1 to +1 of f(x), and that is equals to twice the integral of fx from 0 to 1, and we have divided that into two domains, that is twice the integral of fx from 0 to a third, which is known, and the unknown, which is blue, from a third to 1. Now, we've also known that in the domain a third to 1, we can plug in let x be equal to 2 over 3 plus t, and therefore dx is dt. When x is equals to a third, as you can see, a third minus 2/3 is t is equals to negative a third. And then when x equals to 1, 1 minus 2/3 means t equals to a third. So I is equals to twice the integral of fx from 0 to a third plus the integral of fx from a third to 1 of fx. It is equals to twice the same integral plus the integral of f 2 over 3 plus t from negative a third to t equals to 1 over 3. Now, 2 over 3, f of 2 over 3 t, plus t is equals to, as we previously saw, the absolute value of t minus 2 over 3 squared minus 2 over 3 to the power 3. No, absolute, absolute, absolute. And so when we pull 3 out, we have a third times 3t minus 2 over 3 minus 2 over 3 squared, and so on. And so that means that f of 2 over 3 plus t is a third of f of 3t. Now, since we have this expression, In the blue integral, in place of f of 2 over 3 plus t, we can place a third of f3t. Okay. Now, one thing that obviously we can play around here is we know that, again, the function f is symmetrical about 0. So, and we also know that from 0 to a third is defined, and therefore, instead of having this negative value here, we can say that this integral here is just twice the integral from 0 to a third. Okay. So I is definitely equal to twice the integral from 0 to a third of fx plus 2 over 3, the integral from 0 to a third of f3t. And then we could substitute x back to try and eliminate this constant within the function by saying that let t equals to x over 3, and therefore dt is equals to dx over 3. And so when t equals to 0, x is 0. And then when t equals to a third, x equals to 1. And therefore, our integral, the blue integral focusing on that, is the same as the white that is known. And then in the blue, we have 2 over 9, integral from 0 to 1 of fx. Now, this twice the integral from 0 to 1 of fx is the same as I. So therefore, our I is equals to twice the white integral plus 1 over 9I. Making I the subject is going to be our focus. It means that I minus 2 over 9, I is equals to twice the integral of fx from 0 to a third. And so 7 over 9I is equals to twice that same integral. And therefore, I is therefore 18 over 7 times the integral of fx from 0 to a third. Now, we said we knew what fx was. So we said fx is monotonic within 0 to a third. When f is equal to 0, when you plug in 0 here, 0 minus 2 over 3 is absolute is 2 over 3 minus the rest. So this is the same as 2 over 3 minus the geometric progression with 2 over 3 squared as the initial value over 1 minus a third, which is the common ratio, which is 2 over 3 minus a third, since this entire expression results into a third, which is a third. So f is equals to 0 is a third. And when f is equals to 1 over 3, 1 over 3 minus 2 over 3 is therefore negative 1 over 3 absolute, that is positive 1 over 3. And therefore 1 over 3 minus the remaining terms, which again is the same summation. And therefore that is a third minus a third is equals to 0. So we have this monotonic expression with fx being a third at 0 and 0 at x equals to a third. And so the integral of fx between 0 and a third is therefore just the area of under this line here, which is just the area of this triangle. And therefore that is 18 over 7 times in bracket a half, which base is a third and height is a third. And that is therefore 18 over 7 times 1 over 18, with 1 times 3 times 3, 1 times 9, which is 1 over 18. And the 18 cancels out. And therefore we have 1 over 7. And that is the answer. So it's a very, very interesting problem. I was also able to go out and write code in C++ to try and confirm how this plot looks like. And this is the plot that came out. So as you can see, fx is symmetrical about y, or about x equals to 0. As you can see, as you go in, it is symmetrical about 2 over 3 between a third and 1. And then again, it's symmetrical about this point as you go in. And then there's symmetry again here. So it is an infinitely symmetrical function in as the axis of symmetry changes. So from x equals to 0, x equals 2 over 3, and so it's a highly symmetrical function. Very interesting. If you're interested in getting the code, the C++ program that I used to generate this plot, I would gladly share with you. But it's been an absolute pleasure going through the solution with you. So until next time, it was great hanging with you. Please subscribe to our channel. And yeah, would appreciate your support.